Hello everyone and welcome. I'm Michael, an application engineer at Artec 3D and a long-time photogrammetry user. So today, a short introduction. Let me tell you about Artec 3D first. So Artec 3D is a known worldwide developer of professional 3D scanners and the scanning software, but today I'll show you how Artec Studio can help you create high-quality 3D models from photos and videos faster, easier, and often more accurately than with other software or low-cost 3D scanners. So here is the plan for today. Here's what you'll see. You'll get real-world examples of Artec Studio capabilities. You will see a short workflow demo, which shows how it all works. And then at the end, we're going to talk about some tips and tricks of getting the best results. So before we jump into examples, let's spend a minute and talk about photogrammetry, the technology that is actually used in our software for generating the 3D models. Originally, photogrammetry is a science and technology of obtaining reliable information and measurements from imagery. So today, this concept has evolved dramatically. We now use powerful software to analyze dozens or even thousands of overlapping photos. So the software identifies and matches common features across these images. Then the software triangulates their precise positions in 3D space. And this allows us to build highly detailed and accurate 3D models of objects, buildings, and landscapes, pretty much anything from simple 2D photos. So no need for a scanner, phone, or a digital camera is enough for that. And obviously a computer for Artec Studio. Let's talk about what the AI in the context of our photogrammetry actually is. I believe it's very important to clarify this question. So we do not imagine geometry out of a single photo. We do not invent something. We actually do create a digital twin of the object from the photos. So we do not generate anything based on text prompts. In our case, AI means advanced reconstruction algorithms that makes photogrammetry faster, more reliable, and more accurate. In our case, it also extracts more highly detailed geometry thanks to the use of AI. So now that you know what kind of AI we're talking about, let's start by looking at some example results to see what's possible. So AI photogrammetry delivers incredibly realistic results. Let's talk about our core strengths first. So we can even work with black, shiny, and even semi-transparent objects, featureless items. Small to medium scale objects work the best with the AI algorithm. Then we can even work with low resolution images, so you do not have to use a really expensive digital camera. And then finally, a high photo count is not actually required. We can reconstruct objects from even a limited amount of photos. So here is the first example. Here you can see the Celtic cross, which is around 3.6 meters tall. We have scanned it we have actually taken a video of it with an iPhone 12. A short 30-second video, and we have managed to get a poly count of 900,000 polygons out of it. So let's take a look at the model that we have received here. And I believe it's really important to mention that since this cross is really high and we just filmed the video by walking around it, we have not actually scanned the top part, and yet you see that Artec Studio has reconstructed the top part really well. You can see both the geometry and the texture, even though we we don't have much photos, actually any photos covering this cross from above. And then you could see that all of the fine details have been preserved, and you could see all of those carvings, all of those fine details on our model, on our geometry. So in this case, we're not only getting a high quality texture, lifelike looking model, but we're also getting a really good geometry under the hood. Then that's one of the core strengths that I've been talking about earlier. So Artec Studio is really good at capturing featureless objects. So for example, take a look at this 4R model. You could see that it's really monochrome. It's a single beige color. And so it does not have any texture features. And yet we have managed to reconstruct it with the use of a digital camera Nikon Z6. I have taken 77 photos with it, and we have reconstructed this model at 900,000 polygons. Let's take a look. So here's what we've got. As you can see, we have got really nice looking even color on the textured model, but more importantly, we got a proper reconstruction of the geometry. So the surface is really smooth, and you could distinct different bones between one another. And the definition of those bones, the anatomy here is really good. So this model can be used as a digital twin even for education purposes due to the level of detail that we have got here. So now let's compare it to another leading competitor in photogrammetry. So on the left, you can see the model that we have got inside Artec Studio. And on the right, we can see the result from another leading competitor. So this is where our main core strength comes to use. As you see, due to the object not having any sort of distinctive texture features, distinctive patterns, due to it being a single color, different software tends to reconstruct it with much more noise. You could see that the surface on the image on the right is very bubbly. It lacks proper definition. And it looks low quality with the texture turned off. And yet with Artec Studio, we get a really clean representation of the model, as you could see on the image on the left. Then let's take a look at this example of a 3D model of a small figurine. So in this case, we're going from larger models such as a forearm and even larger Celtic cross to this small figurine, which has been scanned with the use of the Galaxy Z Fold 5 phone, which does not have a particularly great camera. So here we have taken just 102 photos of the object, and we have managed to reconstruct this small figurine at 1.5 million polygons. So let's take a look at the results. Here you could see both the geometry and the texture, and obviously how it looks under lighting on the render on the right. So here we have filmed it inside a light box, and you could see that the colors turned out really evenly. And in terms of geometry, we got a really nice reconstruction. You could see that the cape on the back of this figurine got reconstructed nicely, and the bird looks really pronounced. So this stylized figurine has preserved its charm, its original charm, how it looks in real life. And we have got like really nice both geometry and texture. I believe it's a nice example for hobbyists. So if you're frequently scanning such figurines, if you need to digitize them, to 3D print them, for example, then photogrammetry can be a great application in this case. Let's move on to something more interesting. So here we have an industrial part, a piston, piston head. I have taken 4 videos of it using Nothing Phone 2. So yeah, I have taken videos in 1080p resolution, so they are not particularly high res. And as you see, so let me explain why have I taken 4 videos of it, because this object has pretty intricate geometry. It has deep pockets, it has those cylinders inside. A lot of geometry is hidden in different orientations, so I have taken 4 different videos in 4 different orientations to fully cover this object. And we have reconstructed it at 6 million polygons. Let's take a look. So here is the result that we've got. I would like to draw your attention to the inner cylinders and inner geometry that we have here. So even though it's an industrial object and it has a pretty uniform texture, so it lacks those texture features, and moreover it's symmetrical. You see that the reconstruction turned out quite nicely and the 3D model is really detailed. So if you take a closer look at the thread at the bottom of the piston, you could see that we have even managed to extract geometry from this area, and we have got a really nice definition. And one more time, the other nice thing about this one is that the surface is quite smooth, so we don't have any artificial noise on it. So this model can be easily used for some basic measurements, because I have used a scale cross in this case. I will tell you about this a little bit later on. I would like to mention it right now that the dimensions of this model are pretty accurate, and we can extract measurements from it. Then let's take a look at another example. So here we have digitized a large statue while using multiple cameras in a natural environment. So as you can see right here, we have combined photos from 2 different cameras, from DJI Osmo Pocket 3. It's a wide lens action camera, and then I have taken 30 close-ups with Sony Alpha 6400 to add fine details, as you could see on the left image. So yeah, the left image comes from the Sony camera, and the right image comes from the DJI camera. So in this case, it was not possible to capture the full object, the object from above, with the use of the Sony camera, but with the DJI it has been possible, because we have mounted this camera on a self-extending rod, which extends up to 5 meters in height, and the statue is actually around 6 meters tall. So with this rod we have been able to capture the top part of the statue and get a proper reconstruction there. And then with the use of the Sony camera, I have taken close-ups to add fine details which would not have been that pronounced and would have not been that detailed on the DJI camera. So, and here is the results that we've got. So we've got a really nice reconstruction thanks to a lot of angles. So this is a nice example of scanning to create an asset for cultural preservation, for museums. So in case you would like to digitize real-life monuments or similar structures, photogrammetry can be a really great fit. And so here, if you take a closer look, so even though we have combined 2 different cameras together, the colors have blended in, and they look pretty natural, so we cannot see a distinctive seam. between those two different cameras. So yeah, it's a really nice approach of combining multiple senses. Yeah. Um, one more strength for Artec Studio is the ability to create 3D models of shiny objects. As you can see right here, here is a dress shoe. It's pretty shiny, it's pretty glossy under natural light. So even if we point even if we point soft light at this object, it turns out quite glossy. And so, even despite that, we have managed to get a good reconstruction here. That is the point. So we have shot it with the digital camera, a Canon EOS Rebel, 313 photos, and the poly count is at 4.4 million. So here you could see the final model that we have got with geometry and without geometry. And you could see that the glossiness of this object was not a problem for us. So we have managed to get a good reconstruction of the geometry, even with some photos having glare with them. You could see that the surface is still quite smooth, and we don't have any artificial bubbling or noise on the model. We even got a nice reconstruction of the laces right here, so it doesn't have to be fixed later on in third-party 3D software and something like that. So yeah, here we got a really nice model, which can be a great example for instance, for e-commerce. If you run a shop and you need to showcase different products that you have, so photogrammetry can fit here quite nicely. Then let's take a look at a more difficult example. So here we have this shiny ring. Scanning reflective jewelry is a really tricky task, but we can do that with Artec Studio. So this ring is really tiny, so ring size. And we have taken 141 photos with the Canon Rebel camera. So just to clarify, 141 photos is the amount that we have got after focus stacking. So this is the final amount of the photos that have been used in Artec Studio for the reconstruction. And we have managed to get a really high poly count of 2.5 million. Here is the final result. So take a look at the geometry. Yeah, obviously with focus stacking, the texture also looks really sharp. The clarity is outstanding. And here you can see that all of those sharp details, the text on the ring, even the imperfections on the material are greatly preserved. So yeah, even under such difficult circumstances, we have managed to get a nice looking 3D model. And finally, the last example that I would like to show for now is a face scan with an everyday smartphone. So here we have not used any special lights. We didn't prepare the scene for the scan. We just asked our colleague to sit down, and we have scanned him with a phone, and we have taken a 30-second video, and we have got such a nice reconstruction out of it. So you don't have to take a lot of effort to get a good result. Of course, there is no limit to perfection, but yeah, here we got a nice looking 3D model out of just a video. And then, yeah, of course, it can be used later on for 3D printing, for creating a digital twin of your model, of an actor, and then probably exporting it later on and doing some rigging in third-party software for animation, let's say. One more example that I would like to show is the combination of 3D scanners, 3D laser scanners, and drones for the scene reconstruction. So here we have scanned this tower with our 3D laser scanner, which is called Artec Ray 2. and combined it with a drone data set. Here we have taken around 100 photos with the use of with the drone. So yeah, actually at first we have taken a video and then we have extracted around 100 photos from it. So here, let me tell you why this approach can be beneficial. So we can use a 3D laser scanner in order to get a high level of detail on the facades, for example. So on the facades of this building from the side of the road, we have scanned it with a laser scanner, and then you could see that on the other side there is a steep cliff over here, so we do not have access to this part of the model. We cannot scan it with a laser scanner right here, and that's where the photogrammetry comes to rescue. Yeah, also it is not possible to scan this tower. It was not possible for us, at least, to scan this tower from top. So the top part is not accessible with the 3D scanner, and here we have also used the information from the drone to reconstruct those details. Here is the results. Let me start the video. So here is a final render that we've got. The transition between the laser scanner data and the drone data is really seamless. So it looks like a uniform model, and yet we have managed to get a little more details on the area scanned with the laser scanner. But in the end, we have this nice reconstruction. So let's sum up this chapter. Let's see what we have learned out of those examples. First of all, Artec Studio is capable of capturing almost any kind of surface. We have an efficient data usage, so we don't require thousands of photos in order to get a reconstruction. We're able to extract rich geometry from them, and of course the ultra realistic textures. And finally, it's really easy to use, so we'll see it a little bit later on. I'll show you a workflow, and you'll see the process of how to digitize your object into a 3D model with the use of just photos or video. So now let's talk about the dedicated algorithms for objects and scenes, what actually happens under the hood and what allows us to get such impressive results. So we have 3 different reconstruction algorithms. We have 2 different AI modes. So the first AI mode, the default one, it does not use masks, and it is recommended for 80% of the cases. Then we have the AI mode with masking, and it's suitable for more challenging tasks. And finally, we have classic mode, which is suitable for large-scale reconstruction. Let's talk about the default AI reconstruction mode without masks first. So let's say you're scanning an object that does not have that many features. Your object is small to medium size, and the example of this 4-arm model. So yeah, I would say that it's quite small in its size. Then it's monochrome, so it does not have a lot of features. And then we're going to scan it in a single orientation, so it's a static object. In this case, the default AI reconstruction mode would work really well. So yeah, it works the best for static small to medium objects, which has not been moved, flipped, or rotated in different orientations. Then we have then if you are going to flip or rotate your object, if you are going to film your object on a turntable, or if you would like to get a 360 reconstruction by scanning it in multiple different orientations, then the AI mode with masks would work really well for that. So basically what masking does is it extracts the object from the background. So yeah, you separate the background and your object, and then the algorithms use only the information inside within those masks in order to align the photos and run the reconstruction. So that is why it is possible to flip your object, and it would be done automatically by Artec Studio. So the alignment of those photos would be done, and masking, which is important. So we have the automatic AI masking, which would be performed automatically by Artec Studio. It would recognize the object and extract it from background on its own. And lastly, yeah, one more thing that I would like to mention, that this algorithm is suitable when you have inconsistent background. So for example, if you're scanning outdoors and there are people walking around, then this algorithm can really come to use. And finally, we have this classic mode. It's suitable for large objects and scenes. If you have a drone dataset, please definitely use the classic mode. It would work the best. And finally, so if you're scanning landscapes, then the AI photogrammetry mode would work really well. As you can see on this example, on this slide, here is a really great example that has been reconstructed with the classic mode. Okay, so now it's time for a quick workflow demo. Let's see what happens in Artec Studio, and let's have a walkthrough. Let's see a path of creating your first model out of the photos. So yeah, let's take a look at this arm right here, at this forearm. I have taken photos of it with a digital camera by walking around the object. So as you could see on the video, basically the idea is that this forearm remains static, and then I walk around the object and take a lot of different photos from multiple different angles and at different heights. So I'm going to reconstruct this forearm in a single orientation. Yeah, so let's see how what happens on the Artec Studio side. Once we have taken the photos, you can drag and drop your folder into the Artec Studio, and then you can double-click your photo set in the workspace, and here you could see all of the photos that you have captured. So then go to Tools, Create Preview, and here I'm going to set the static scene photo set capture setup. Well, because our scene is static. Yeah, and then the next step is optional, but I'm going to disable fast processing to get a better result. Yet still, you could enable it if you would like to make your processing faster. Then I'm going to run the algorithm. And here is our preview. It appears in the viewport right here. Then you can double-click this photo scan and adjust the bounding box. So you could see that there are a lot of points floating around our main object. We do not need them for the reconstruction. So here you could see that I'm adjusting the bounding box. Everything that is highlighted in green is going to be reconstructed, while everything highlighted in gray is going to be ignored. So then it's time to go to Tools, Create Model. So here you would see that the AI processing mode is set by default. I'm going to set the detail level to enhanced to get a better level of detail, but it's not necessary. So if you would like, you can set it to normal to speed up your processing. And then finally, you would see that the extract object from background option is unticked by default. That is correct for our object because we have not moved it. Our scene is static. Then once I run the algorithm, you could see our model appearing on the screen, so you can inspect it, rotate it in the 3D view. And now let's clean it up. So I'm going to Editor, Eraser, and here I'm just selecting the polygons which I would like to erase. So here we have some adjacent geometry. I have cleaned it up. And here is our model. So before texturing, I'm going to optimize the mesh here. It reduces the poly count without sacrificing the quality of the model. So let's take a look at the mesh, at the wireframe before and after results. So here is what we had before. You could see that the mesh is really sparse. It has a lot of triangles. And then, so after the mesh optimization here, you could see that the mesh became denser, and yet the level of detail has been preserved. So yeah, that is why it's called mesh optimization. And then I'm going to texture this model at the default settings, and here is our result. So basically no post-processing necessary. Here is what we've got. And now it is ready for export. So you can now right-click your model, go to export, export meshes. Here you can specify a custom directory where it's going to be saved. And then select the model and texture export formats. I'm going with OBJ and PNG. And so yeah, I'm exporting this model. So yeah, this is pretty much the whole workflow of creating the model. So we will send this video after the webinar. So in case you would like to give it a try on your own, which we highly encourage you, of course, to do. So you can use this tutorial as a guidance for creating your first 3D model. So now let's take a look at the main features of the AI photogrammetry. We have a mode for automation, which is called workflows in Artec Studio. So basically, it's a mode that allows you to create or use a sequence of operations, a sequence of Artec Studio tools. So as you could see right here, this workflow is called a photogrammetry workflow, which creates models from photos or videos. And here you could see our sequence. So this is what we have seen on the video before. This is the whole process, but automated. Sorry. Basically, you can create. So basically, in order to run this workflow, all you have to do is import your photos or your video in Artec Studio, and then go to Tools. And at the top, you would find those workflows. The photogrammetry workflow is predefined in Artec Studio, but you can even create your own ones. So all you have to do after importing your data is running this workflow, and then you will get your 3D model with just a single click of a button. Another feature is the ability to combine multiple cameras, as we have seen earlier on the example of the statue that we have scanned, but it can be also used in different use cases. So for instance, the most popular use case of this feature is combining drone datasets with digital camera datasets. So basically you take one aerial photo set, and then you take photos from ground to add in fine details, and then you combine all of those photos together to get a really detailed reconstruction with the crucial geometry being reconstructed in a high quality because of photos from ground. So yeah, there might be more use cases, for example, combining different lens like macro lens and regular lens. So there are a lot of applications to this use case, but it's pretty niche, so we are going to move on. It's possible to get accurate textures. With photogrammetry, so we can use masks in order to get rid of unwanted artifacts, unwanted color artifacts in our model. So here on the right, you can see some texture projection from some adjacent objects. So here you can see that we have some white color at the top of our model right here, which is not actually present on our real life object. And yeah, this might happen. This might happen because of some adjacent overlapping objects projecting this texture onto our objects. And we can enable the option to use masks, and then we're going to get rid of this artifact really easily. As you could see right here, we got accurate texture without any wrong projection, because only the color within the masks have been used in order to capture the model in this case. So yeah, I think it goes without saying, but just to clarify, of course, this option is only available if you have calculated masks for your model. Then one more powerful feature that we have is called chop image prioritization. You could enable it in the texture tab, and here you could see how it works. So basically, on the left image, this option is turned off. On the right image, it's turned on, and you could see that even though we have used the same resolution, the same 4K resolution in both cases, the model on the right has a better clarity, has a better definition right here, and the texture looks much more professional. So yeah, this option is pretty self-explanatory. Artec Studio prioritizes sharp images over the blurred ones in order to apply the texture. So here is another example. You also have this slider to adjust the power of this option, the weight of this option. So yeah, it is particularly useful for if you are taking the videos approach. So if you're making photogrammetry out of videos, then it's usually harder to control that all of the frames are within focus and they are perfectly sharp. Then this option might be even more useful than as opposed to photos approach. But still, even with photos, it would of course be beneficial. Now let's move on to another feature. So Artec Studio supports scale bars for measurable results. We also do support scale crosses. So you might use metrological scale bars and metrological scale crosses, which have been calibrated, which have been factory calibrated. So all you have to do is go to Artec Studio, add your scale references in this window right here. So you specify the distance between targets and you name your entity. And then if you have this scale bar, scale cross on your images, then you're going to get proper measurable results. But still, yeah, so of course there are some rules to be followed. Here is an example of using a scale cross. You don't need a metrological one actually necessarily if you don't need a really high accuracy. If you don't need a very high accuracy, you could actually print out our scale cross, which is being shipped with Artec Studio in a PDF format. So you can print it out. We have it available in both A4 and US letter formats. So you can use your printer to print it out. Then you place it in your scene next to your object or underneath your object so that the targets are visible, are clearly visible. So if you take a look at the image on the right, you can see this Buddha figurine next to those targets right here, and you could see that all 4 targets are clearly visible. So it's really important. In order to get measurable good results, it's really important that you have at least 10% of photos with full scale cross or scale bar visible. Then, of course, so try to make as much photos as you can from as much angles as you can with the scale cross or scale bar visible, fully visible within those frames to get better results. So yeah, you need to have enough angles with both the object and scale cross present in those photos to get a nice measurable result. So here on this slide, you could see an image, an image of a color map, which has been which has been created as a comparison between our photogrammetry model and the model created with a laser metrological scanner. And you could see that actually the accuracy here that we get with the photogrammetry is around sub-millimeter. So the deviation that we get from our reference model lies below 1 millimeter. So on the second image, you could see those labels. They have those values of the deviation of the points in different areas of the mesh. Those values are in millimeters. So here, as you see on the image, the largest deviation that we have is around 0.8 millimeters from the reference model. So the point is that you can get a pretty accurate result with photogrammetry if you follow the filming procedure correctly. Of course, the scanners would be able to provide you with a much more reliable and accurate results, so meaning metrological scanners, of course. But if we compare photogrammetry to cheap 3D scanners that are not certified as metrological, then you could get even better accuracy with photogrammetry in comparison with those cheap 3D scanners. Don't just make models, do more with Artec Studio. So we have a lot of processing tools apart from photogrammetry part in Artec Studio. So let's start with the mesh optimization that we have seen earlier. Here is a really nice example. We have created this AI photogrammetry with 3.2 million polygons. You could see the mesh on the left. So yeah, you could tell that this mesh is unnecessarily dense. We don't need that much polygons to represent such surface. So we can optimize our mesh and reduce the poly count. So the mesh optimization algorithm is smart. It leaves more polygons in areas that have more details. So if you see on the image, the helmet has more polygons, and the eyebrow, all of those features, they have more polygons, while the dense area, which does not have that many details, has a sparser wireframe. So Artec Studio does it automatically. It defines which geometry has better level of details automatically and tries to preserve it, and it reduces the poly count on areas. It tries to prioritize reducing poly count on areas that don't have that much details on them. So yeah, it's a really nice tool if you're going to export your model to some web viewer, if you're going to work with this model later on in different third-party software. Optimizing this mesh to have less polygons would make it easier to deal with it later on and run different operations in different software. Then we support the construct tools. We have primitive fitting. So let's take a look at this on the example of this industrial part piston that we've scanned. So here I have defined an area on the mesh, and then I fitted the cylinder into it. So yeah, as you see, this cylinder has been fitted pretty accurately in this cylindrical feature. And then we can get the measurements out of this cylinder. We can get the height, we can get the radius. So we can also fit a different primitive, and we can add constraints to them. So for example, in this case, we have made one one cylinder parallel to another, because we know that those holes, those openings, they should be parallel to each other. One more tool that we have under the Construct tab is called Auto Surfacing. So it's used to convert your mesh, which comes from photogrammetry, for example, to a CAD model. Yeah, as you can see on the right, we have a CAD representation of our mesh. It's a quick way to convert your model if you specifically need the CAD. If you specifically need the CAD for your object. Then we have tools for quality inspection. One of them is called distance mapping. So here, what you do, you may create your results with the AI photogrammetry. You may create your model. Then you can import your reference model, either CAD or Mesh, into Artec Studio, align those models, and create this heat map, this color map between those two different entities. And here, so you compare the deviation from one of your model to a different one, to the reference one. So this can be, for example, used if you're running a 3D printing shop, let's say, and yeah, your 3D printing parts, and then you would like to compare your 3D printed part to the reference model that has been actually used for production. So if that use case is suitable for you. So to sum up this part, we have a hassle-free export as well, and Artec Studio comes as an all-in-one solution with it. So for most of the operations, you won't need different software packages. It will be enough for like 80% of tasks associated with 3D printing, e-commerce, CGI tasks. But in case you have some advanced applications, advanced tasks, you may continue your work in different software on the models that you have created with the AI photogrammetry in Artec Studio. So for that reason, we have this hassle-free export. You could easily export your model to SolidWorks, Geomagic, Autodesk Maya, Blender, ZBrush, Zeiss software, and of course much more different software packages. So here are the main export formats that we support. You could see them on this slide right here. Now let's talk about how to get the best out of photogrammetry. So even though our software handles most things automatically, a few simple techniques can help you to get the best possible results and improve them even further. So first of all, let's point out all of those different points that are important, all of those different bullets that are important during the scene preparation. First of all, you need to have even and soft lighting. You need to have sufficient feature capture. Try to achieve sharp images of good clarity and ensure that you get all of the angles and use a good trajectory for filming your model. Let's take a closer look. So first of all, yeah, here the example that we have, I know it's a bit dramatic, but yeah, it conveys the idea pretty well. How to get the best out of your lighting. So first of all, if you're scanning indoors, then consider using lightbox or additional lights in order to get even lighting, as on the example at the top. Avoid shadows, overexposure, glare, if possible, for the best results. And if you are filming outdoors, it's very important to prevent lens flare. So try not to film against the sources of light, especially if they are too strong, like sun, for example. So yeah, photos with lens flare, of course, we won't be able to extract any good features out of them, and yeah, so they are going to be useless in our case. So yeah, sorry, one more thing that I forgot to mention is that if you're filming outdoors, The best weather conditions for that are cloudy weather, overcast weather. So in this case, your whole sky is like a huge softbox, and then you get a really good soft lighting without any overexposed bright spots on your model, and then you can get a really nice even color. So one standard setup that you can use for the photogrammetry, you can see it on this slide. You can use a light box, a turntable, and your camera mounted on a tripod to get even soft lighting easily and to basically get enough angles, get sharp images because your camera is mounted on a tripod, and you can get enough, you will get enough features, especially if you add additional texture features to your turntable, as you could see right here. They will help with the alignment of the images in the 3D space. So as you see in this lightbox case, there are multiple lights from multiple different sides of this cube, which help you ensure good even lighting. So this setup is pretty easy. It's pretty cheap to set up this, and then it can really come to use, especially if you're scanning a lot of small to medium parts in high volumes on a daily basis. Then this setup is the one that I would recommend. Let's talk about the features next. So yeah, we have been talking about the features this whole webinar. Now let's talk about what those features actually are. The texture, so as you could see on the example on the top image, you can see an object with a rich texture. So there are a lot of different colors in unique patterns. You could see that they are non-symmetrical, and it would be very easy for the software to define which photo belongs where. And then so the alignment of those photos would be much better. So if you're just starting out with the photogrammetry, I would recommend you to begin with such rich texture objects to get better experience, because it's easier to reconstruct such objects. And then once you get comfortable with that, you can move on to objects that don't have such great texture, because yeah, they might require some additional preparations and some additional techniques to get them right. You can see this frame, this moto frame on the bottom image, which essentially does not have any texture features. It's a solid single color, it's monochrome, so it would be much more difficult to get a reconstruction out of this object in comparison with the top one. But so of course, still we can reconstruct those poor texture objects in case the images fail to align and your object does not have like a rich texture. Then you could add in more texture features by yourself, either to the background or to your object itself. So yeah, you could add some targets to your object. For example, you could add additional textures to the background as well, as you could see on this example. So I have printed out a few sheets with some unique text on them, and I have placed them underneath our object on the background. And as you could see on the image right here, now it would be much easier for software to define which image belongs where and to align them in the 3D space. While on the bottom image, you could see that our object is pitch black and it does not have any texture features. So it might be problematic for the software to get some angles right. So yeah, that's one way to address this issue. Then it's really important to get sharp and focused images. So the top example is really good. You don't have any motion blur. The whole object, the whole seashell is within the depth of field of the camera, so it's within the focus range. And you could see that there are no blurred out parts on this model whatsoever. So this is the ideal scenario which we need to pursue. So the bottom example here, you could see a bad example of a photo. It's blurred out, and yeah, so this image may result in poorer reconstruction of your object, while the top example would get you a much better result. So yeah, lastly, one more important thing is to have good level of detail in photos. But yeah, it's also, this topic also overlaps with good lighting, so that, for instance, you wouldn't have like overexposed images. Yeah, so the last advice that we have, last but not least, is to have a good trajectory for capturing your object. It's really important to cover your object from all of those different angles right here. What you want to do is to film your object in a dome-like trajectory, as you see on the image. So there are a bunch of photos registered from different sites. So basically, like a good starting point, if you are not familiar with photogrammetry, is to walk around the object and make one photo each 10 degrees, which would result in 36 photos per one circle, and then make photos from a higher position. So walk around the object one more time while filming at an angle from higher position. This would help to cover more angles, to get a better reconstruction of the geometry, and this would help the software to align those images between each other. So it's also really important to cover all of the geometry, not to get any blind zones. If you have blind zones, then obviously the software does not know which geometry is positioned in this exact area. So yeah, that is why it is really important to have enough angles and enough photos. And finally, there should be a good overlap between those photos. So if you're just starting out, I would recommend you to try the video approach first. So if you're filming video, then it's much easier to get a good overlap because yeah, so you are filming continuously. But yeah, if you're taking photos, then make sure to take photos with a reference of each 10 degrees. Then your overlap would most likely would be enough in most of the cases. So if you follow all of the recommendations that we have discussed above, then you're going to get this nice, clean-looking model. You see that the our color is really even. We have preserved a lot of details on the geometry. We don't have any artifacts. And then finally, so we don't have any double geometry, and our reconstruction looks really sharp, nice, and ready for export. All right, so now it's time to wrap up our photogrammetry webinar. So to summarize, Artec Studio is a powerful all-in-one solution for creating 3D models from photos and videos. You can get high-quality geometry and textures. We have built-in editing, reverse engineering, and inspection tools. You have flexibility to work anywhere, anytime, with just your phone or camera. And our AI photogrammetry is a great alternative to low-budget scanners. It's suitable for multiple applications. And now let's talk about those applications. So we cover the markets of e-commerce, education, museums, cultural preservation, healthcare, film and video games, reverse engineering, and forensics and law enforcement. So thank you for your time today. Thank you for attending our webinar. We hope you enjoy exploring Artec Studio photogrammetry, and we'd love to hear your feedback. Share your experiences with us on social media, Reddit, or reach out directly So we're always happy to hear how you use our tools, to hear about your applications and use cases. Depending on where you are, have a great day or a wonderful evening, and happy scanning.